Coral reefs are the heartbeat of our oceans, supporting 25% of all marine life, but they are under a silent, invisible attack: ocean acidification. By the time we see physical bleaching, it's often too late. Current monitoring is either too slow, requiring manual water testing, or too expensive for wide scale deployment. We created Coral Sentinel to bridge this gap between real time AI and predictive digital twins.
So, this is the whole setup integrating both hardware and software for our Coral Sentinel system. The main idea is the implementation of sensor nodes that form a mesh network throughout the ocean. This is a novel idea that we've implemented, along with the fact that we will be collecting live sensor data for real time monitoring. This is the master node, and these are the slave nodes. This is a small scale setup. These slave nodes will collect sensor data, such crucial information such as pH and temperature, which affect the health of the coral reef, and send it to this master ESP32. This will then send it to the server, which will help the professionals to visualize the health of the coral reef effectively. Here you can see the stream of live data that runs over this code. You can see that each node, either reef 4 or 2, so we've implemented 4 so far, sends a continuous stream of temperature and pH. And this is the live stream. This is the novelty that we've implemented, which will then be transferred over to this system, which will.
So, what we've done here is that all of the information that is coming, we have we've connected via a physical USB connection. So this is going distributed into a fully distributed ROS2 Humble architecture. So this allows us to scale from a single sensor to a global network of coral sentinels with zero latency. So here, as you can see, we're getting a 3D perspective of all four of the nodes that we have. Now, of course, the final product will be a will be an interactive dashboard. As you can see, we have all four nodes that we've taken as an example from the Arabian Sea in the Lakshadweep reef. So node 1 and node 4 are blue because they're stable. Their pH levels, their temp, the CO2 is all normal as per our trained ML model. But then node 2 is yellow and node 3 is severely in danger, and that's why it's blinking. As you can see, our current stream of data is also shown here, and then everything else is just accessible. And that's all for our project.
We've also implemented a camera. We've also implemented a camera that will capture the image of the coral, and our ML model will help identify what species it is for effective mapping of health based on species. So we've also implemented a depth sensor, which will help the system identify how deep into the ocean it is. And these will all be integrated in one system, which will effectively help us monitor the health of coral reefs and therefore help us sustain the marine ecosystem.